Welcome to this explainer. Today, we're going to demystify the internal architecture of OrbitTest. And honestly, look at how it completely rethinks browser automation from the ground up. If you've ever wrestled with automation frameworks, you already know the pain of maintaining fragile scripts. The ones that just break the absolute second a developer tweaks the underlying HTML. Well, today, we're pulling back the curtain to see how OrbitTest solves this by shifting the whole paradigm away from structural testing and straight toward visual intent.
Let's just dive right into this modern end-to-end platform. OrbitTest isn't just another simple test runner. No way. It's a fully modular ecosystem designed specifically to simplify how we write, execute, debug, and scale our tests. It brings together browser control, CI/CD orchestration, and some seriously smart visual diagnostics, all under one roof.
Test what users see, not what developers write. That quote right there, that perfectly captures OrbitTest's core philosophy. For years, traditional frameworks have basically forced engineers to interact with applications through deeply hidden implementation details. I'm talking about brittle CSS selectors and incredibly fragile UI hierarchies. OrbitTest just throws that whole concept out the window. It shifts the focus entirely away from that hidden HTML structure and puts it directly onto the actual visual user experience.
Okay, so here's our architectural map for today's explainer. We're going to cover 1. Traditional flaws. 2. The architecture journey. 3. Shell versus core. 4. Mission control. And finally, number 5, the Orbit Vision Engine. Let's get into it.
Part 1. Traditional flaws. The problem with structural testing.
This really gets right to the heart of the problem. Look at the stark contrast here. On one side, we've got an unreadable, super brittle structural selector, an XPath pointing to the second button in the fourth div. Now, the exact moment a front-end developer adds a new container somewhere on that page, bam, your test fails. But on the other side, we have OrbitTest's intent-first approach. It's a clean, totally human-readable command focused purely on user intent. Just await orbit.click checkout. It's readable, it's highly maintainable, and most importantly, it actually reflects what the real user is trying to do.
Moving on to Part 2. Architecture journey, the path of a test.
So, how does a test actually run? Well, this workflow represents the high-level journey. A user's test enters the interface layer, which is known as the Orbit shell. From there, it gets handed straight over to Orbit Mission Control for orchestration before finally executing inside a totally isolated browser environment, which Orbit refers to as a capsule. This kind of modular setup is genuinely one of the platform's greatest strengths. It keeps the outside super simple for you, while the inside remains massively scalable.
Number 3. Shell versus core. The front door and the hands.
It's absolutely crucial to understand this division of labor. Think of the Orbit shell as your command line front door. It's exactly what you interact with in your terminal to initialize projects, load your configs, discover test files, and run commands like OrbitTest run. Now contrast that with the Orbit core, which acts like the hands. The core is the developer-facing API layer where you actually write out your test steps, the clicks, the typing, the assertions. It completely hides all those low-level complexities of browser protocols and WebSocket communication, so your automation stays readable and, crucially, stable.
Part 4. Mission control, the brain of orchestration.
So once a test is launched through the shell, it enters Orbit Mission Control. You can think of Mission Control as the essential traffic cop, or really, the brain of OrbitTest. It handles all of the heavy lifting of execution behind the scenes. When you're running a massive suite of tests, you absolutely need a system that decides what runs when, how resources are allocated, and what happens when something inevitably hiccups.
And these capabilities show exactly why Mission Control is so powerful. It guarantees maximum reliability by automatically handling parallel runs across multiple workers, managing fail-fast logic, catching those annoying flaky tests, and aggregating results for your CI/CD pipelines. And the best part? It does all of this natively. That means you get highly scalable automation in GitHub Actions or Jenkins without having to write a single extra custom script. It's a real game changer.
Finally, Part 5. Orbit Vision, seeing UI like a human.
To truly see the UI like a human user does, we literally have to bypass the DOM entirely. Think about it. Traditional locators are completely blind to modern applications. If you're testing a video game, a dynamic trading chart, a whiteboard tool, or an interactive map application, that content is being rendered using Canvas, WebGL, or GPU layers. There are literally no regular HTML DOM nodes for you to click on. So OrbitTest pivots entirely to a visual language here. It allows the automation to see the interface exactly as a user does.
So how does it actually do that? Orbit Vision identifies visual elements using some really specific techniques. It allows you to automate by targeting exact X and Y coordinates. It can perform pixel validations, dynamically search for and click specific hex colors, and even wait for visual stability before it interacts with anything. This means you can easily automate a complex drag-and-drop visual app or even a remote desktop just by looking for colors and pixels. It completely solves that canvas and WebGL blindness that totally plagues other frameworks.
As we wrap up this explainer, I want to leave you with a bit of a provocative question to really challenge your current automation paradigm. Take a hard look at your test suites right now. Are you testing how developers build your application, or are you testing how users actually experience it? OrbitTest's intent-first approach, its modular architecture, and those incredibly powerful visual engines really challenge the old ways of doing things. It proves that by focusing on readability and visual awareness, we can make testing far more reliable and vastly less frustrating. Thank you so much for joining me for this deep dive, and I hope this sparks some great new ideas for your own automation journey.